Okay, so lesson number 9 is logarithmic scales and applications. So there are applications in the real world, scales in the real world that rely on a logarithmic scale. The first is the Richter scale. So the Richter scale is named after an American seismologist, and it's used to measure the magnitude of an earthquake. So a magnitude of the earthquake is the amount of energy that is released, determined from the logarithm of the amplitude of waves recorded by the seismograph. Being logarithmic, a difference in 1 unit corresponds to a factor of 10 difference in intensity, which means that an earthquake of magnitude 9 is 10 times more powerful than a magnitude of 8, and 100 times more powerful than a magnitude of 7, 1,000 times more powerful than a magnitude of 6. So that's why when the news is reporting on an earthquake and they talk about an 8.5 earthquake being dangerous compared to a 6.5, it's because it's 100 times more powerful. Okay? To give you an idea of what a 1.0 on the Richter scale is equivalent to, it's a blast of 14 kilograms of TNT. That's 10 times the 0 reference point. Okay? Any earthquakes having magnitudes in excess of 6.0 are considered to be dangerous. The largest recorded at the printing of this book was a 9.5 in 1960 in Chile. In North America, the largest one was 8.4 in 1964. But there are getting to be more powerful earthquakes as the earth continues to shift. And the bad part is when an earthquake hits a populated area because of all of the structures that collapse. That was a problem that happened in Mexico a month ago, was the buildings that collapsed due to the earthquake. So if we look at class example number 1, an earthquake of magnitude 8 is how many times as intense as an earthquake of magnitude 7? So each level is a factor of 10. So which one's more intense, the 8 or the 7? The 8. And how many levels? Just one time. So 10 to the power of 1 or 10 times. So a magnitude of 7 is how many times as intense as a magnitude of 3? 10,000. Or the other way to look at it, 10 to the power of 4. I went up 4 levels. What's the difference between the statement in B and the statement in C? A magnitude or an earthquake of magnitude 4 is blank times as intense as a magnitude of 6.
You're going down in magnitude?
I'm going down in magnitude. So how many levels am I going down?
2.
2. So instead of it being 100 times, it's 1/100 times. Or 10 to the negative 2. So an earthquake of magnitude 4.8 is how many times as intense as 6.8? One over 100. 10 to the negative 2. So in 1960, there was an earthquake in Chile. What was the magnitude of that earthquake? 9.5. Thank you. And in 1976, there was an earthquake in Italy. What was its magnitude? How much? 6.5. So that 1960 earthquake in Chile was how many times as intense as the one in Italy? 1,000. 3 levels. And then in 1983, there was an earthquake in Colombia. What was its magnitude? 5.5. So the earthquake in Chile was how many times as intense as the one in Colombia?
10,000.
10,000, 10 to the 4. Okay. In 1966, there was an earthquake in Turkey which had a magnitude of
6.9.
and then there was one in 1933 in Japan that was
8.9.
okay. So how many times as tense was the Turkey earthquake as the Japan one? 1/100. Good. Okay. So if we look at the next page, a question arises. What would happen if we wanted to compare the intensity of the Chile, which was 9.5 in 1960, to the one that they had 45 years later, that was 7.8. What happens when I try to compare those? What's the problem?
It's gonna be a decimal.
It's going to be a decimal. What's going to be a decimal?
Like it's not gonna be like a perfect whole number. It's gonna have more to it.
It's not a perfect whole number. The ones that we did on the previous page were exactly 2 levels up or 4 levels down or however. What is this? 9.5 to 7.8. How many levels is that? 1.7 levels, so to speak. On the previous page, what was one of the ways that I was abbreviating my levels? I was doing to the power up. What was the power representing? The levels. So if my levels are 10.7, what's the intensity going to be? What am I going to do with this 1.7? 10 to the power of 1.7. So all of this stuff here basically describes that. So if I go 10 to the power of 1.7, what do I get? Actually, that's down here. So we had the 9.5 minus the 7.8, which gave me the 1.7. How many times the intensity is that? Michaela, what did you get?
About 50 times?
Yep. So remember, 10 to the power of 1 is going to be just 10, and 10 squared is 100. So 50 is going to fall somewhere in between those two values. Okay, so now I'm going to go up and do all this algebraic work. So to compare the intensities of the two magnitudes, consider the following. The magnitude of an earthquake is given by the formula magnitude equals the log of I over I0. I is the earthquake intensity and I0 is the reference intensity. So if we were to find the difference between the magnitudes of two earthquakes using the formulas, we rewrite M1 as I1, the intensity of the first earthquake, divided by the initial intensity, minus intensity of earthquake 2. Our laws of logarithms tell us that when we're subtracting these, right here, when I'm dividing these, I can rewrite them as a subtraction. So that's how I get the log I1 divided by, or minus log I0. And the same thing with the next statement. So if I expand that out by removing the brackets, take a moment to do that. So if I remove my brackets, I have the initial intensity, intensity of magnitude 1 minus the initial intensity minus magnitude 2 plus the initial intensity, because the negative and the negative would make this a positive. This would then cancel out my initial intensities, and I would get log I1 minus log I2. I can go backwards in my law of logarithms, and instead of subtraction, write this as a quotient. And then the last part of this statement, from here, I can rewrite this into exponential form. So I have a base of 10, so I get 10 to the power of this value equals my argument. So in other words, which is what we've already said 5 minutes ago, if I subtract the intensities, it's 10 to the power of that difference, which is what we did in this example. Okay. This is going to remain very much the same for the other scales that we look at throughout the rest of the lesson. So we're going to look at class example number 3. A major earthquake of magnitude 7.5 is 375 times as intense as a minor earthquake. Is the magnitude of the minor earthquake going to be greater or smaller than 7.5? So read the statement again. A major earthquake of magnitude 7.5 is 375 times as intense as the minor earthquake. So will the magnitude of the minor earthquake be more or less than 7.5? Less than. Because this number is bigger than 10. It's bigger than 1. If it was smaller, then it would be a fraction times intense. So question B says, use the formula I1 over I2 equals 10 to the power of the difference in the magnitudes to determine the magnitude of the minor earthquake. This right here, that's the intensity difference. That's my 375. That represents taking the difference between the two intensities and finding that ratio. Equals 10 to the power. Because we've said that the minor earthquake's the smaller one, that tells me that it has to be 7.5 minus x, minus that unknown value. Okay. At this point, there's a couple of ways that you can solve this equation. One of the ways that you could solve this equation is you could rewrite this in in logarithmic form. So if I write this as a log, what's the base of my log? 10. What's my argument? And then what will that equal? And I want to get x by itself.
Could you solve the log and then move it to the other side?
I could.
Yeah.
So if I solve the log, this is should be a straightforward log to solve because my calculator is a base 10 log. So in my calculator, I would type in log 375, which gives me some decimal number. What decimal number does it give you, Pearl? 2.57, okay? So then how would I get x by itself? How would I solve for x?
Well, you actually make it positive, right? So you have to move it over and then move the 2.57 over.
Okay.
Other way.
So then what do I get? 4.92 something. So the magnitude would be 4.9. The only thing that I'll caution you about is if you are going to change this to a decimal, make sure that you leave 4 to 5 decimal places so that when you're rounding your answer, you're rounding it appropriately. Or you could put into your calculator 7.5 minus log 375. So that would be one way that you could put that in. Okay, so the next logarithmic scale has to do with comparing sounds. So, oh, there we go. So the loudness of a sound was measured in bells coming from Alexander Graham Bell. The current unit that we use when we're measuring sounds is a decibel. And if you go back to prefixes, deci means 1/10, so a decibel is 1/10 of a bell. The Bell scale, like the Richter scale, is logarithmic, which means 1 bell is a difference of 10 times, and 1 bell is 10 decibels. So this one, when we're working with it, we just have to keep in mind what unit we're measuring in. If we're measuring in decibels, we need to change those numbers to bells, because the intensity, the logarithmic scale, is based on bells. Leaf rustling is considered to be 10 decibels, which is 10 times as intense as the threshold of hearing. So the threshold of hearing is when everything is quiet, what you can actually hear, when absolutely everything is quiet. So one of the best times to figure out your threshold of hearing is when we have a lockdown, because everything goes quiet for a period of time. That becomes your threshold of hearing. And when we talk threshold of hearing, we're talking about a normal person's hearing. If you have a hearing impairment, of course your threshold of hearing is not going to be the same. Conversation is 60 decibels, unless of course you're me, then it's probably closer to 75 or 80. A whisper is considered to be 30 decibels. A rock concert, which is what I'll be attending tonight, is 120 decibels, so I won't be able to hear tomorrow. A jet engine is 140 decibels. So that would be 14 bells. So you think a jet engine, 14 bells, that's 14 levels. That's 10 to the power of 14. So do you understand why when you're at the airport you see the guys wearing the headphones? The noise canceling ear protection? That's why. Because if you're around jet engines all day long, you will go deaf. Threshold of pain, 125. That's when the sound is so loud that it is actually hurting your ears. And the rock concert is just below it. So again, that's why now, more than ever, you will see people when they go to concerts, they're wearing earplugs because the sound is too loud. People working in around loud machinery, if you're working around compressors or boiler rooms, a lot of times they will have ear protection for that. How many of you wear ear protection when you're hunting? Same thing. When you are hunting, the blast from gunfire can be damaging to your ear. So those are all things that you have to be careful over time, because your eardrum is something that over time becomes less able to bounce back from damage. Okay, so if we look at class example number 4, a power saw, which is 120 decibels, is how many times as intense as a telephone dial tone? So how many levels am I going? If I'm going 120, I've got 80. In terms of bells, I have 12 bells and 8 bells. So that would be 4 levels. So a power saw would be 10 to the power of 4, or 10,000 times as intense as a telephone dial tone. A jet engine is how many times as intense as the threshold of pain? How did you get the 20?
Oh, sorry, I just went 145 minus.
Okay. So 14.5 minus 12.5, and that gets you 2. So then this would be 10 to the 2. So I would get 100 times. So the thing to remember, each level is a power of 10. Okay, so a whisper is how many times as intense as a conversation? 10 to the negative 3. So that would be 1/1000. Okay. Have you ever noticed that people with hearing aids, when they're in a room that's filled with multiple conversations, they start playing with their hearing aid, they start turning it down? Part of that is because with your human ear, without using a hearing aid as an amplifying device, you have the ability to tune certain things out. And mothers have perfected this ability. We can tune out a lot of stuff. But when you have a hearing aid, because the sound, you don't have that ability as well. As you get older, your ability to tune out all of that background noise does become more difficult. And when you've got a hearing aid that's not filtering those sounds coming in, you're picking everything up in a classroom or in a room in general, it can be very difficult to be in a room when there's multiple conversations going on because you have a hard time focusing on the conversation you need to listen to. Okay, so again, comparing the intensities of sound, this is the same as comparing the intensities of magnitude for an earthquake. It's 10 to the power of the difference between the intensities. The thing to remember is when I'm dealing with the sound, I have to be in bells. If the measurement's given to me in decibels, I just have to divide it by 10. Okay? So question number 5. How many times more intense is the sound of a piano playing than a whisper? So how would I calculate that? What would you do? Okay. So 6.7 minus 2.2, which gives me what? 4.5. And what is 10 to the power of 4.5? So is that to the nearest whole number? That would be 623. So piano playing is almost 32,000 times as intense as a whisper. Given that a decibel equals 10 times the log of the given intensity divided by the initial intensity, show that the decibel level for the threshold of pain has a sound intensity of 10 to the power of 12.5 times the initial intensity. So if I fill in my question, the decibel, that is my threshold of pain, so 125 equals 10 times the log of I divided by I0. Okay. If I wanted to isolate what was in this bracket here, how would I do that? What would I do first? 10. Do exponent, but if I exponent, I'm just going to start to complicate things. What can I do instead? Divide. I can move it over to the other side. So if I divide both sides by 10, I get this. So this part here in the brackets is linked to the log. How do I separate it out?
Exponential form.
Put it in exponential form. What's the base? 10. So I get 10 to the power of 12.5 equals intensity divided by the initial intensity. How do I isolate for I? How do I get rid of the initial intensity? Multiply. Oh, yep. Okay, so we're going to move on to the last scale that we look at, which you guys should have knowledge of. The pH scale. So the pH scale, if you weren't aware of this, represents the expression, the power of hydrogen. So it measures the extremely wide range of the hydrogen ion concentration in substances. So the pH scale, we have neutrality, and we go to acidic, and then we go to basic or alkaline. Okay? So similar to the Richter scale, the pH scale is logarithmic. A difference of 1 unit in pH is a 10 difference in intensity. The thing to remember, as I move in this direction, what is happening to my substances? They are becoming what?
Acidic.
More acidic. As I move this way, they are becoming more basic or more alkaline. So we have to read the questions very carefully to see which way we should be subtracting and how we should be expressing things. It's a little bit backwards and it's a bit harder. The pH scale in terms of 10 times or 100 times or 10 to the power of whatever times intensity becomes a little bit more challenging because of the words acidic and alkaline. So if vinegar has a pH of 3, it is 10 times as acidic as tomato juice that has a pH of 4. Even though 4 is the higher number, because 3 is more acidic, it ends up kind of looking backwards. It also means that vinegar would be, battery acid is 0.5, so vinegar would be 10 to the power of negative 2.5 times acidic as battery acid, because battery acid is considered to be more acidic. So again, it has to do with reading the question carefully and being familiar with the idea of the pH scale. Household ammonia, which is at 11.5, is 10 times as alkaline as milk of magnesia and 1,000 times as alkaline as seawater, given their pHs. So if we use the chart on the side here with all of the solutions, we're going to use the chart and we're going to identify the pHs of, fill in the statements. So tomato juice, which has a pH of what? 4, is blank times as acidic as pure water. Pure water has a pH of 7. So how many levels is that? 3 levels. The question is, does this become a 10 to the positive 3 or to the negative 3? Positive 3, because the tomato juice is more acidic. So this becomes 10 to the positive 3, or 1,000. Okay. What's the pH of eggs? 8. And pure water is 7. So the question is, eggs are how many times as alkaline as water? So the difference is 1, but does this become 10 to the positive 1 or 10 to the negative 1? Positive. Because I'm talking about alkalinity. If the question had been written, eggs are blank times as acidic as pure water, what would your answer be? 10 to the negative 1. Because of which end of the scale that you're on. Which is the next question. So eggs are 10 to the negative 1 as acidic as pure water. Okay. Milk of magnesia is 10.5. And blood is 7.5. So the word that we have to fill in is either going to be acidic or alkaline. Because 3 is my difference, so there's my 1,000 times. So milk of magnesia is 1,000 times as blank as blood. Is the word acidic or alkaline?
Alkaline.
Yep. Because I'm closer to the alkaline end. If it had been 1/1000th times, then it would be acidic because I'm closer, because it's the acidic that is taking over. Okay, so E says what is 100 times as acidic as normal rain? So what's the pH of normal rain?
5.
5. So if I'm looking for something that's 100 times more acidic than normal rain, what's my pH that I'm looking for?
3.
What has a pH of 3?
Vinegar.
Vinegar. Okay. Eggs that have a pH of 8, they are 1/10,000th times as alkaline as. So this 10,000 has a power of 10 would be 10 to the power of -4, or 1/10 to the positive 4. So which pH am I looking for? Am I looking for a pH of 12 or a pH of 4? What word am I looking at? What word should I be looking at?
Alkaline.
So if the eggs have to be 1/10,000th as alkaline as something else, am I getting closer to bases or closer to acids or closer to bases? If I'm at a number of 1/10,000th. I'm getting closer to the bases. So this would be the washing soda. Eggs are 1/10,000th time as acidic as washing soda. Does it make sense that my washing soda would be more alkaline? Did I say acidic? I meant alkaline. So my washing soda is extremely alkaline. Can you get a chemical burn with an alkaline? Yes. Okay. So again, you can compare the acidities or the alkalinities by subtracting their pHs. But the word, and this is the word that's going to screw you up on a question, is acidic and basic. Which way should you be? So seawater is how many times as alkaline as pure water? So what is the pH of seawater? 8.4. Because the question says pure water, swimming pool water, and seawater have pHs of 7, 7.4, and 8.4 respectively. So pure water is 7. your question, Devin?
No.
So the question is, how many times as alkaline is seawater compared to pure water? So I know it has to be a 10 to the power. And I know I have to do something with the 8.4 and the 7. I have to find the difference between them. The question is it 8.4 minus 7, or is it 7 minus 8.4? So look at the word alkaline. When I'm going alkaline, it's the bigger minus the smaller. When I'm going acidic, it's the other way around. So what is 8.4 minus 7?
1.4.
So what is 10 to the power of 1.4?
25.11.
So to the nearest whole number, 25 times. Which answers the question, why does salt water burn my eyes? Because it's 25 times more intense, more alkaline than pure water. It's going to be more sensitive. Seawater is how many times as alkaline as swimming pool water? Would become 8.4 minus 7.5. Which is how much?
.9.
Okay. And what is 10 to the power of 0.9?
7.9.
So to the nearest whole number?
8.
8 times. Some of you have seen this formula already. The pH of a solution is defined as pH equals the negative log of the hydrogen ion concentration expressed in moles per liter. So a patient gave a urine sample that was found to have a pH of 5.7. What's the hydrogen ion concentration? Answer in scientific notation to 1 decimal place. So in my formula, pH equals negative log hydrogen ion. Where does 5.7 go? For the pH. So 5.7 equals negative log hydrogen ion. I want to get this by itself. So I'm going to need to separate it from the log at some point, but before I do that, I need to deal with the negative. How do I deal with the negative? Put it to the other side. So 5.7 equals positive log hydrogen ion. How do I separate this log out? How do I separate the log from the hydrogen ion? Exponential form. So I have a base of 10 to the power of, and that will equal my hydrogen ion. So if I do that on my calculator, 10 to the power of negative 5.7. And my calculator nicely puts it into scientific notation for me. To 1 decimal place, what would this base number become? 2.0. Because it says 1 decimal place, I have to put the 0.0 in there. And then times 10 to the power of what? Negative 6. And what are my units? So the hydrogen ion concentration, which is expressed in moles per liter. For some of you, chemistry is all coming back. Okay, so the last question, determine the pH of the solution if you're given the hydrogen ion concentration. So pH equals negative log 3.4 times 10 to the negative 4. So in your calculator, negative log 3.4. There is a button on your calculator that you can use to represent times 10 to the power. I can't see where it is on the calculator. Second comma, thank you. It's this EE button. So E means times 10 to the power of negative 4. Or you can actually just physically type the whole thing in. So I get 3.46. So to the nearest tenth would be 3.5. So just to show you, I could type that in as times 10 to the power of negative 4. Same answer.
3.4 second long.
Yeah. So I get a pH of 3.5.